Hi, so here I'm going to show you an example of using StreamSets to fetch data from IoT data sets. It could be sensor data. In this example, I am going to use sensor data, which is being captured over Azure Event Hubs. From there, we create a pipeline in StreamSets to fetch data from the event hubs, do a little bit of aggregations, and then we're going to persist that data directly into ADLS Gen 2, but at the same time, all the aggregates that we are calculating in Stream will also be persisted into Azure SQL Data Warehouse. So in this example, I am populating all the data for the data warehouse in a table called sensor data. So let's go ahead and make sure this is my table and I have no data currently in it. For my ADLS Gen 2, I'm going to populate data in a partition manner inside my container and a folder called sensor data, which will auto-create partitions with the year, month, date, and every hour it's going to create separate partitions. You can add any type of partition logic as you need. There are multiple functions available inside StreamSets to allow you to do that. It could be even a record value that's coming in from the sensor data if you want to partition accordingly. However, I'm just going to make it time-based for all the data that's coming in. So for my ADLS Gen 2, this is the container I'm using. As you can see, I have no folder called sensor data underneath it. StreamSets will auto-create it on the fly once I start running it. Now, the data that's coming in from Azure Event Hub, this is the config I have. The Event Hub name is Drupal-demo. The rest of the configs are pretty straightforward. So I'm going to start running this pipeline. Click on play. And right now there's no data from the Event Hub. I'm going to simulate some data to be pushed into the Event Hub. So I have another pipeline that's just going to generate data going into the same Event Hub name. So let's start this up. And as data is going to get persisted into Event Hub, we'll start data being trickled into this pipeline and going into our specific destinations that we have plugged in. Now, as data is flowing, let me show you what's happening to this pipeline. So I'll take a snapshot here, which is a great feature where you can identify data as it's flowing in at a specific point in time. So I'll capture a snapshot and we'll go and view it. Once I view the snapshot from the source, I see the data that's coming in. So I get a sensor ID, its value, and the timestamp at which it was taken. This processor is doing a windowed aggregation over 5 seconds. It's getting me the average sensor value for each of the sensors that's coming in. And for all of those records, it's going to give me an aggregate value that will be pushed into SQL Data Warehouse. Right now, it hasn't completed the 5 second, hence we don't see it. But if I create another snapshot, we might be able to see this. And all the data set also gets persisted into our Azure Data Lake Storage Gen 2. Now, I'm going to close this snapshot and go back to the Storage Explorer, refresh this page, and we should see our hierarchical directory structure being created here. Under my container, we'll have all right, that's taking some time. There's some connective issue. Let's go to our SQL Data Warehouse in the meantime. If you recall, we didn't have data in our table before. Let's run this. All right, so I do have a connection error. Let me try again. There you go. So data is being persisted in our data warehouse, and for each sensor ID we're getting the average that was calculated, the 5 second rolling average that was calculated via StreamSets, and then the timestamp at which it was calculated. Let's go see if we can check our storage for ADLS Gen 2. And there you go. We have sensor data hierarchical structure created under the container name. And inside that, we have our partition also created with year, month, date, and the hour in a 24-hour format created. So data is being appended to these files. It'll make sure it creates a large file, rolls it over, and starts creating files accordingly. Let's go back to the pipeline. One of the things that happened here is, as I'm evaluating sensor data that's coming into the flow, I realized that there are certain attributes of the pipeline that I wanted to create triggers for. At certain points in time, for some of the sensors, I was getting non-average values for these specific sensors. So what I had done is I created a data rule wherein if the average value of the sensor was above 240, which is my average, then I want StreamSets to automatically create a trigger alert for me. So this trigger was activated, hence it's shown in red. It also shows us a few records which matched this condition where the average was above 240. So I can see which sensor, the name. So one, the average was 253, well above the average here. And what this did is it created a trigger for me, not only in SDC, but it also triggered a webhook for me such that I got a webhook alert sent to my Slack channel. So you can see that it sent me this webhook automatically. So you can take care of alerting based on any type of rule you want to create in real time when you're analyzing sensor data on the fly. Now, let's go look at again, I'm going to stop the pipeline. Let's go look at our data lake storage for the files that get created so you get an idea of how you can push out data into ADLS Gen 2. So I'll refresh this page. From a temp file, it gets renamed to be an actual file. Let's go and download it so that I can preview this. And I'll say open. So it's downloading this file, transfer from here to my local. And let's go and quickly preview that data set. So I have my file here. Let's open with text edit. And you can see that I have sensor ID, the sensor value, sensor timestamps, all of them getting persisted into our ADLS Gen 2 location. I hope this helps, give you an idea of how you can use StreamSets in order to fetch data from any different variety of sources you have, but at the same time using Azure connectivity options, whether it's Event Hubs, ADLS Gen 1, Gen 2, SQL Data Warehouse, to be able to not just move data between these different connecting endpoints, but also provide transformation logic on top of it and create event processing as data is coming in from different sources. Thank you for listening. Enjoy.